Everyone, always difficult to work out what to put in the networking intro. I thought I need to put in the minimum to get you able to use containers, understand them, and probably to the level that Kubernetes isn't too far away. That's where we're heading. So I decided to have a wee look about a home router, because everyone's got a home router, and then we'll talk about some of the things in the cloud that are just equivalent. So this is my router, came with Vodafone. They're my internet service provider. As you can see in my house, I've got 14 devices in the Wi-Fi and 31 in the network. The majority of them are Raspberry Pis, to be honest. And the web address, or the router address, is 192.168.1.1. The significant bit is the .1 at the end. It's the first device in that network that's 192.168.1. And that's going to make sense in a wee minute. But it's just a bog standard home router. You've got the same at your house, and there's going to be simple configurations. So there's some special IP addresses, and they're called private IP addresses, and they're what you're going to have at home or in a company. So a large company, probably all your IP addresses begin with 10. So there's a Class A network, there's about 16 million numbers. That's what most companies use, and they divvy it up into smaller networks. And we'll show you how to do that in a future video. We've got 172. You might get that, or you might have a company that's got some stuff in AWS and a 10 and stuff in Azure and a 172, or maybe you're hybrid and you've got 172 in your premises and your Google Clouds at 10. But basically, these are the address spaces. And the 192.168.0.0 is what your home network is normally on. So the Class C network. So Class A is for big businesses. Class B is smaller, so 1 million addresses. And the 65,000 in the Class C, but typically we split that into the ones in the bottom. But we've got other special addresses. Multicast, you might come across them, or you might not, but all these IP addresses are assigned to that. And then on Windows specifically, but on any device, if your IP address is 169.152, it means your DHCP has not found stuff, and it's just allocated itself. There are stuff called link local that you can do, but for now we can just ignore it. If your machine's got that IP address, it's not talking to it. So the bottom two are the two typical network ranges you get in a house. So you get 192.168.0.0 and /24, just means there's 250. Sometimes I've got that depending on my ISP. Currently I've got with Vodafone, I've got the 192.168.1.0/24 on the right hand side, and it gives me 250 IP addresses, roughly. So that's that. Hopefully that makes sense. So if you see an IP address that's not in these ranges, it's a real internet address. And obviously there's a few tens of millions, hundreds of millions of IP addresses that could be. So a network connection, the TCP IP packet has got a source IP, a port, a destination IP, and port. So what we're typically concerned about the destination IP and port. And we use DNS names like www.cnn.com or bbc.co.uk. So that's called DNS over the top, but underneath it, there is an IP address. So DNS is just a lookup for the IP address itself and port. So there's common ports. So if you do http://www.bbc.co.uk, that's HTTP on port 80, and if it's the secure version, HTTPS. Whatever, that's from 443. These aren't hard and fast rules. You could, if you wanted, you could muddle the services up, but normally people just tend to stick to these ones by convention. There's 65,000 ports, so obviously I've given you the ones that I think we might come across in these series of lectures. We've got Oracle databases in 5121, but we're probably going to look at other types of databases such as Postgres or MySQL. So they're in different ports, but we'll come along and we'll get to them. But most of the stuff we're going to use is port 22 and port 4 for SSH, and secure copy, and port 80 and 443 for HTTP. So this is how to find your IP address. So the first command is running on my Mac Studio, and it's ifconfig -a. So that shows all about the interfaces. And the grep 192, pipe to grep 192, just shows list the lines with 192 in it. So my Mac Studio is actually on 192.168.1.48. It actually has a virtual machine also running on it. So if you've watched any of the other videos, all the machines I put on my network are on 192.168.1.253. So we can just tell my Mac Studio it's got an IP address itself, and it's using another virtual address for the virtual machine running within it. And then if we go from that, we SSH to the Raspberry Pi that I actually have as 222. So I can remember, it's easy to remember, it's my main Pi, or it's the one I use for configuring them. And then in the second window, we can see if we ifconfig -a is not available in the Raspberry or Ubuntu. I think it's the same with Windows. So the command is IP address, and again we just do the grep 168 just to listen to the same lines. And this is 192.168.1.222. So we're expecting that, having just jumped onto it by IP address, but to make it easier. And the host name is Pi 4822. No rocket science, it's a Raspberry Pi 4 with 8 gig of RAM, and it is 22 in the network addressing, because I use 200 above. The next command is it's just a command. So if you are in a browser and you go to Google and type what's my IP, this will give you your IP address that you're on the internet. So your router in your house has an external IP address on the internet. So in my case, it's 92.168.159.139. With Vodafone in the UK, that's a dynamic IP address. So I might have that IP address for a week, I might have it for a month, or I might have it for an hour. Typically when the router reboots, I get a different IP address, or any time they do update it, but sometimes it changes. So that's that. And then the final thing is to do with private IP addresses again. Before you go out to DNS to find names, you can actually put it in a host file. There's a different, it's in the Windows System 32 drivers, etc. folder in Windows, but on a Unix or Linux system or a Mac system, it's etc hosts. So if you cat etc host, the grep pi just means list ones with pi in the title, and tail -5 goes just list the last 5. So you can see from a naming convention, I've got at least 28 pies in sequence. They're all Raspberry Pi 4s, and there's no rocket science, but what this means is if I was trying to type in pi, so I'll take the second one in the list, 4825, it doesn't need to go out to DNS to find out the IP address of that. It's because it goes to its host file first. So you can override anything by using the host file. It's not good for experiments. We'll be using it a lot, but it's not good practice in a real machine. Okay, so this is my network router, and this is DHCP, Dynamic Host Control Protocol, and that just means you can use a dynamic IP address. So if you've got a machine and you just plug it in the Wi-Fi, it's going to get an IP address in the range set, and typically it's going to be 192.168, and then it's either a 0 or a 1, and then it's something between 1 and 255. So that's what that is. On my specific router, you can see on the right hand side, it issues addresses between 192.168.1.2 and 199. So all my Raspberry Pis that I want fixed IP addresses, that's why they're above 200. I've got the network from 200 to 250 essentially. So I've got 50 IP addresses that I can set manually. They'll never change in my private network. And that's how that works. So let's have a look at one of the Raspberry Pis. Now, this is Ubuntu from 5 years ago that's been continually patched. The network configuration changes all the time. So the uname -a lets you see the exact version of the operating system. And so that's not too important. So the configuration for this version of Ubuntu is a file called etc netplan 50cloudint.yaml. it's very similar on different OSs. The file name can be different, but essentially whatever GUI you use, it changes the file in the file system. And this one, we just look at it, and the configuration is there's networks. So there's one network interface card. It's called ETH0. DCHP is false, which means don't give me a random IP address when I connect to the network. I want to use a fixed IP address. So the address we set in the addresses is 192.168.1.2222. I think it's 3 twos, not 4 twos. I think I said that. And the gateway is 192.168.1.1. So if we remember, that's the IP address of the router. So if something is on the subnet, the local subnet 192.168.1. whatever, it goes and talks to it. If it's a different IP address, it goes via the router, and that's the router address, and then the router tells it where to go after that. And name servers, these are the DNS name servers where it links the name like CNN.com or Disney.com. So what it goes, my computer goes, it checks the local router, the Vodafone hub, so 192.168.1.1, and also if it can't find it, it checks 8888, which is Google's DNS servers. So you might recognize this number eventually, but all computers, they're all the same underneath. You either set DCHP or not, and if you don't, you set the IP address, you tell it the gateway, and you tell it where the DNS servers are, and it's all quite simple. So let's have a look. So typically, just now we'll be looking at clients. So say your machine is going to enzosdad.com, which will be my web address. I've not registered, I bought the domain, I've not stuck it anywhere. But if you do HTTP enzosdad.com, the client calls the server. And the second example is HTTPS instead of HTTP. I was going to do all the handshaking of certificates and all that, but that makes this thing way more than 10 minutes. So all we need to do is import port 80, the first one, port 443 is for the second one, but you can override that with a colon and a port number. And then, so these are both fictional examples of how the web server is going to be configured, but also you could use a proxy in the middle, which is more typical as you get bigger and want to use things as a career. So enzosdad.com goes to a proxy server, and then the proxy server jumps to a private IP address behind the proxy, and it calls just HTTP to the web server is called web server, and that's how that works. And so, in the final example below, is we've got traffic as a proxy talking to NAN, which is a workspace configuration for doing automation of AI stuff. Again, that's on a private IP address. But if you go and watch one of my previous videos called NAN, it shows you how to set it up, and we use this configuration. So again, we'll go from client anywhere on the internet, and the traffic proxy is going to route us to the NAN. It was just the default configuration of this system, but I thought we've got an example of how we've done this, and we've got deep dive configuration if you want to go and look just now, when it's not specifically a networking tutorial, but we'll do a more complicated network tutorial or smaller bits in more detail. And it's very simple. So on the Raspberry Pi, you might use traffic as your proxy. On AWS, Azure, and Google Cloud, it's very similar stuff. Cloud load balancing, going to a firewall, web application firewall on Azure and AWS, and it's called Cloud Armor and GCP. And then we go to an AWS, it's API Gateway, it's APIM Manager on Azure, and it's Apigee on Google Cloud. But it's the same thing. So we're going to go into a load balancer, firewall screen it for all the naughty hacks and rule them out, and then punt it onto an API behind the scenes. So when we go from the simple stuff we're going to do in your Raspberry Pi or on your virtual machine we're using, we can see it's the same principles on the cloud, and we'll get to the cloud eventually and how to scale the stuff. Okay, so the next thing on or it's the last thing I think on my home router we're going to look at is IP port mapping and NAT mapping table. So NAT is everything in a private IP address in my house goes out via the router, and it gets the router's external IP address passed on it. So that's how the internet was running out of IPv4. everyone knew IPv6 is coming along, but nobody really uses it. Portugal does. I've been in Portugal before and it doesn't have IP4, but most places it's IP4 we're going to use, still the old one, and that just means everyone, so like in our house, we've got, I can't remember how many devices, 50 devices, they only use one IP address. Same with a company. A company might only use one IP address for going on the internet. So the port mapping, the static port mapping is the interesting stuff. So 192.168.1.253, if you look at any of my videos so far, that's the address I use for a VM, and we run the stuff in it. And you can see my IP, so this is like a firewall rule. So it's saying anything that comes in on port 443 to my external IP address, which was a 90 dot something just now, just gets forwarded to the virtual machine. So this means that anything I have in the virtual machine is available on the internet because I've left this firewall rule open. They call it port mapping here, but it's very much what a firewall is. So all we do is explicitly define what we want allowed. So the one that's important is the HTTPS 192.168.1.253, 443, and then the router goes to 443 in that VM. So there's this described above. So currently my IP address is the 90.240. So if a client on the internet typed HTTPS and my IP address, it would take the proxy and that would forward it to the virtual machine I'm running. And again, the picture below is user, goes via my router, and the image I'm actually running is WordPress for this demo. So I've got a video on how to build WordPress and how to build this. But essentially, that's how to get WordPress on the internet via an IP address. And obviously, we need to get DNS to make it a pretty name. But this is how to serve something at home. I don't necessarily recommend leaving the firewall rule open on your router at home long term. But certainly while you're playing an experiment, it's safe enough. Okay, so network translation. We might have seen from that table, my MacBook Pro is on 192.168.1.2. And it calls for all traffic, because this is gateway 192.168.1.1, which is the router, the Vodafone router. It goes on the internet and it goes to the website. So every device in my home network on the left hand side appears with as if the source when it goes onto the internet is 92.40.159.139 with a random port between 0 and 65,000. And that's what a network address translation is. It switches it, and the Vodafone router or the NAT proxy keeps a cache of everything, and that's it does a translation, so that we might have 100 calls going out to the internet. It does all the transfers, and then anything on the website only sees the 90 as the source address, even though we know the private real source is 192.168.1 dot something. And obviously Google Cloud's got Cloud NAT, AWS has got a NAT gateway, and Azure's got something similar. So you're going, why would the cloud want to know a specific IP address? And you don't have to set them up, these are optional. So I would configure them in a previous life to be, if you know where any system on your cloud exits the internet and you can say it's this IP address, you can let your supplier know all your traffic is going to originate from your NAT gateway, so that they can set their firewall rules to only allow traffic in from you. So if that makes sense. So if you're a mortgage quote system and you say, I want to buy a mortgage, give me the best prices, then if you tell all the vendors that you're actually getting the quotes for the mortgage from, your IP address and what URL you're coming, they can lock it down to allow you in. So it's just it's just a nice way of securing traffic to a third party. So that's why you would use Cloud NAT. You could also, if you've got, say you've got a system built in AWS and your DR system's built in Azure, you can lock down where any system that hands over. So it's a good security mechanism. DNS. This is probably one of the most important things on the internet. So I've got a MacBook Pro, and I'm wanting to say, so we've got the host file, and we've also got caches, and we've got caches in the router. There's something called time to live that you can set, and we'll play with that in an advanced session. But just now, all you need to do is, if we are looking for enzorsdad.com, just example website. I've not built it yet, but I will do it. My MacBook Pro will go and ask the DNS resolver, which is obviously the Vodafone router, and it goes, oh, I don't know that. I'll go into the dot server. So it's never written down, but like .com has actually got a dot at the end of it that's never used, and that's called the DNS root servers. And somewhere in your laptop or your Raspberry Pi or your cloud machine, you have an address hard-coded of about 12, 15 root servers. It's going to call one of these. And because the server we're wanting is enzorsdad.com, the root servers know where the .com server is, and it's called the top-level domain server. So the DNS resolver asks the root servers, where's the .com resolved? .com, it gives back the address for the .com, and that comes back. So it asks the .com then, where's enzorsdad.com? It goes and finds the name servers for enzorsdad.com, and it asks it where www.enzorsdad.com is. It gives the IP address back, and then the Mac Pro directly calls www.enzorsdad.com. So it's a recursive way, and obviously if the address was like testlab.enzorsdad.com, there'd be another sequence in the step going asking testlab.enzorsdad.com where's the host name that I've just forgotten what I've called it. But so your router at home is going to follow the recursive route, and then you've seen that Raspberry Pi configuration. I had 8.8.8. There are two name servers that a lot of people are familiar with that you can just skip all this resolving. Google has a DNS service, and Cloudflare as a service on 1.1.1.1. I would recommend that for any of our labs to put as your second IP address in case your router or your home router can't find the address you're looking for. You've got a get out of jail free card, because DNS can be ropey, and it's good to have a plan B that's transparent to everyone. I mean, I'm going to have one mention that's a bit complex just now, but DNS, we've been through the IP addresses. We know the private ones. So I've got a 90 IP address that's assigned to Vodafone UK. It's going to have a chunk of the 90 range. That's going to be known in a lookup table as a UK IP address because I'm in the UK. So what Amazon, Azure, and Google all have is they've got things like global traffic management. And when I used to build internet sites, we used to have F5 global traffic management systems, and they're DNS-based load balancers. So if you've got multiple data centers, so basically you do a DNS search for mybank.com. You go to mybank.com, and rather than giving you the IP address, it gives you the IP address of the data center nearest you, and that's how global companies work. Is they can send people in the UK to a UK data center. They might send people in Germany to a Dutch data center because it's the nearest data center. But all that's done at a DNS level. They work out what your IP address is, and then the DNS gives you the IP address of the nearest data center, or the data center pre-selected to serve your country, and lets you get around legal stuff as well. Basically it's DNS is manipulated at the other end, but I thought you won't need this just now for your Raspberry Pis, but I thought you might find it interesting that people listen to where you're coming from for your DNS queries and then can give you answers back depending on where you are. So I thought that was a really interesting sideline.